Did you know that after the World War II, plants were exposed with radiation to produce useful mutation known as atomic gardening, which resulted in today's peppermint and red grapefruit? Marhaba! Welcome to another episode of Chemistry is Easy with Mr. Jesse. For this tutorial, we are going to answer relevant questions that came out in the past system-wide quiz. Isotope of an atom with unstable nuclei is called a radioisotope. Radioisotope is also known as radioactive isotope. Radioactive isotope. The force that holds the protons and neutrons together in the nucleus of an atom is called the nuclear force, and this nuclear force is very strong, and this is the reason why in the nucleus, even if you have protons there which have the tendency to repel each other, but because nuclear force is very strong, the nucleus of the atom remains intact or whole. Different forms of radiation are given off by a radioactive source passed through a screen, then between two charge plates to be identified. So this is our radioactive source here. W is... Now, since W is attracted towards the positive plate, therefore we can say that the charge of this W is negative, and a radioactive particle that has a negative charge is a beta particle, so therefore W is a beta emission. The most penetrating form of nuclear radiation is... So if we are going to look at this figure, an alpha radiation can be blocked by a paper or metal foil or thin clothing, whereas a beta radiation can be blocked by a metal sheeting or dense wood or heavy clothing, while a gamma radiation can pass through paper, metal sheeting, and in fact it can only be blocked when you have a thick wall of lead concrete or a metal concrete. So therefore the answer to this question, the most penetrating form of nuclear radiation, would be the gamma radiation or the gamma rays. Which of the following is not a type of radiation? Now, beta is a radiation. Delta is not a type of radiation. There's no such thing as a delta radiation. We also don't have a theta radiation. However, we have gamma radiation. So to answer the question, which is not a type of radiation, therefore that would be B and C. So the correct answer here is choice E. Which of the following is true about nuclear reaction? Statement 1 occurs only when nuclei emit radiation. So it is partly correct, therefore it is not entirely true, because a nuclear radiation can also occur when nucleus would split or combine. So therefore we cannot say that this is true because of the term only. Next statement, it is associated with very large energy changes. Yes, this statement is true for nuclear reaction. Temperature does not affect the rate of the reaction. This is also true because there are no factors that could affect the rate of nuclear reaction. Therefore, statements 2 and 3 are correct, and that means choice D is the best answer. The subatomic particles involved in a nuclear reaction are So protons are involved in a nuclear reaction, and photons are not subatomic particles. So when we say subatomic particles, that refers to protons, neutrons, and electrons. So when we talk about nuclear reaction, protons are involved in it. Neutrons are also involved in nuclear reactions, as well as the electrons. So therefore, the correct answer here is 1, 3, and 4, and that leads us to choice D. So again, photon is not a subatomic particle. It's not a subatomic particle. An element with atomic number greater than blank is said to be radioactive. Now this is a knowledge question, and the correct answer here is letter E, that is 82. So any number that is an atomic number, any element that has an atomic number greater than 82 is said to be radioactive. Which of the following radiations has a charge of positive 2? So the radiation that has a charge of positive 2 is alpha, because here X-ray, though they are radiations but the charge is 0, beta radiations would have a charge of -1. Alpha again is positive 2. There's no such thing as a theta radiation, and gamma radiation would have a charge of 0, or it doesn't have a charge. So the correct answer here is letter C. Which of the following is produced by a radioactive source? Now, an X-ray is not produced by a radioactive source. It is actually produced when electrons jump from a higher energy level to a lower energy level. So it is the movement of the electrons that releases X-rays. It is not a product of radioactive source. Now, gamma rays are actually products of radioactive sources. So, and it's not beta emission but beta particle. So this term here makes the statement wrong, as well as alpha emission. We don't call it alpha emission but alpha particles, and there is no such thing as a theta emission. So therefore the correct answer here would be gamma rays. But if it was beta particle or an alpha particle, then these choices would also be correct. The decay of iron 53 by beta emission produces, so we have iron 53, and iron has an atomic number of 26. If it undergoes beta emission, therefore it produces a beta particle, and a beta particle would have a symbol 0, -1 with an E, plus, so therefore the sum of the atomic numbers on the product side should be equal to the atomic number on the reactant side. So therefore the atomic number of this element here should be 27, so that if we have 27 plus -1, it would give us 26, and therefore the mass number here should be 53, because 0 plus 53 would give us the mass number on the reactant side, which is also 53. And to determine this element here, we have to look at the periodic table and look at element with an atomic number of 27, and that is actually cobalt. So therefore, if we look at the choices here, we are actually down with A or B. But what should the correct answer be? So this particular product here is actually known as cobalt 53. So this 53 here is the mass number, and that means our correct answer is letter B. The decay of thorium-230 by blank results in the formation of radium-226. So let us analyze this question. We start with thorium-230. It has the atomic number 90. and it forms, or it results to the formation of radium 226, atomic number 88. So we have to make sure that the mass number on the product side is equal to the mass number on the reactant side, as well as their atomic numbers. So if we look at here closely, on the product side that's 230, but I mean on the reactant side it's 230, but on the product side we only have 226. So therefore this particular decay actually produces a particle with a mass number of 4. And if we look at the atomic number, on the reactant side it's 90, and on the product side it's 88. So therefore the other product should have a atomic number of 2. And this particular particle is an alpha particle, or a helium particle. This is an alpha particle. This means then that the answer to this question is an alpha emission. So the decay of thorium-230 by alpha emission results in the formation of radium-226. And that concludes this tutorial. Once again, always remember, chemistry is easy with Mr. Jesse.